And in this corner, we have Sam's Chemistry Corner.
Welcome everyone to Sam's Chemistry Corner. Today we will be discussing matter and change. Again, what is chemistry? Chemistry is the study of the composition of matter and the changes that matter undergoes. So, then what is matter, you ask? Now, matter is anything that has mass and occupies space. I'll put out there. But that doesn't mean it has to be visible to be matter. The air that you breathe is an example of invisible matter. Now, there are ways to describe matter and specify what it is exactly that you're talking about. Properties used to describe matter can be put into two categories, extensive and intensive. An extensive property is a property that depends on the amount of matter in a sample. For example, mass, which is a measure of the amount of matter an object contains. And also volume, a measure of the amount of space an object takes up. Intensive properties, however, are properties that depend on the type of matter in a sample and not the amount of matter. For example, hardness, density, the ratio of an object's mass to its volume, which would be intensive because it only depends on the composition of the sample, not the size. Every sample of a given substance has identical intensive properties because they all have the same composition. So gold will retain its density. So, what is a physical property? Physical property is a quality or condition of a substance that can be observed without changing the substance's composition. For example, color, texture, hardness, melting point, boiling point, solubility, malleability, ductility, and conductivity. Solubility is the reaction of a substance to liquids, ability to dissolve. Malleability is the ability to bend or mold into other shapes. Ductility is the ability to form into or pull out wires. And conductivity is the ability to allow heat or electric current to pass through it. These are also all examples of intensive properties because they do not change in terms of that specific substance. For example, pure copper can scratch the surface of pure gold because copper is harder than gold. Copper is also a better conductor of heat and electricity than gold. However, gold is more malleable than copper. So, you can use these physical properties to distinguish between different substances. As you can see, some of these properties can actually also be found in your Regents reference sheet in reference table S. It's important to understand physical properties as it can help you differentiate between two different substances. For example, the melting point. As you can see, it changes between, for example, helium with a melting point of 1 Kelvin. And also, carbon, which has a melting point of 3,820 Kelvin. That's a big difference. So, you'll be able to distinguish between carbon and helium. Also, you have your boiling point, which can change depending on the substance. And density is also one of these examples. Now, let us discuss the states of matter. State of matter number 1, solids. A form of matter that has a definite shape and volume. It will also not change according to the shape of its container. Particles tightly packed together, often in an orderly arrangement, and it's almost incompressible, meaning it's difficult to squeeze into a smaller volume. For example, a coaster. This would be considered a solid because it has a definite shape and volume. So if I were to, anywhere I would put this, it's going to stay this shape as long as I don't touch it. It will also, if I were to put it in a glass, it's not going to change to the shape of that container. Inside are particles tightly arranged and tightly packed together in an orderly arrangement. And it's going to be difficult to kind of squeeze it. I mean, if I try hard enough, maybe. Another example is ice cubes, where this is solid water, I guess. This is an example of the particle arrangement for a solid. As you can see, there are tightly packed particles right here. They barely move. They only slightly vibrate. They're going to be in an orderly arrangement, which is the reason why they are pretty durable. Now, let's talk about the second state of matter, liquids. They're a form of matter with no definite shape but a definite volume. So they will have a set volume such as 15 milliliters, 1 liter, anything like that. However, when you move it into a different container, it will take the shape of that container. They're not very compressible, and the particles are arranged loosely and less tightly packed in a solid so that they can easily slide past one another. So imagine a solid, but a lot less tightly packed, or less tightly packed, actually. They're going to be kind of slightly spaced, stuff like that. Example, water. As you can see, is a glass of water. And right here, this is a set volume. This will not change unless it undergoes some sort of change. Right here, this is set volume. However, if I were to move it into a different container, hopefully I don't spill it on my... As you can see, it has now changed the shape to fit with the container that's in. That's how they work. As you can see, this is the liquid particle arrangement. And over here, that's a terrible drawing, but you can see that they're only loosely packed and that they can slide past one another. There's a lot more vibration in this arrangement than a solid. However, as you can see, it's not in an orderly arrangement. It's kind of just moving around. Finally, we have gases, a form of matter with no definite shape or volume. That means the air, for example, takes the shape of this container right here. Whatever room you're in, that's the shape it's going to take. Or even in a little container, gas will take up that space. They also have no definite volume because they expand and they expand out, therefore creating a greater volume if in an more open area. They're very compressible. For example, you can put it in a pressured container and put pressure on that gas. They're also widely spaced and they move in a random straight line motion until they collide with the walls in the container. For example, if I have a gas particle, it's going to hit in a straight line motion and move around like that. You'll see that more later. Vapor. People like to use this term interchangeably with gases. However, vapors are more specifically the gaseous state of a substance that is usually a liquid or solid at room temperature. For example, water. Water is a liquid at room temperature. However, it can become water vapors because that is the gas version. Particle arrangement. This is the particle arrangement for gases. As you can see, there's a wide space between these two, a lot more than liquids and solids. They also will move in a straight line. That's not straight at all, but they will move in a straight line until they collide with a container like this, and then they will bounce off and move in another straight line until they collide with another wall of a container or wherever. So these will move in a random straight line motion. It's kind of just anywhere. And they will keep hitting and bouncing off and bouncing off. Think like a bouncy ball. You bounce it off a wall, it'll come back straight line until it hits the wall. There you go. That's just how it works. Think like that. Now, how do you go from one state of matter to the next? Physical changes. That's how you do it. During a physical change, some properties of a substance change, however, it keeps its composition. For example, you change ice to liquid water. Some properties may change, however, it will still keep that composition. For example, melting ice to water. Boiling that water in your kitchen, when you're gonna cook spaghetti or something. Freezing, turning that liquid water back into ice. Condensation, that would be turning steam. When steam fogs up your mirror, it turns back into liquid. Breaking, splitting, cutting, and grinding, I guess. These physical changes can be reversible or irreversible. Physical changes that involve changing states of matter are reversible. For example, if you freeze water, you can melt that water back. So that would be considered reversible. However, cutting hair, filing nails, cracking an egg, those are examples of irreversible physical changes. If you cut your hair, you're not going to be able to put that hair back. It will grow back eventually. Now, different substances can exist as different states of matter at STP. What is STP, you ask? Standard temperature and pressure, STP. An internationally agreed upon set of standard conditions to be used in measuring during experiments in chemistry. These would be the standard, the normal conditions when you're doing an experiment. So, for example, pressure. That would be 101.3 kilopascals or 1 atm if we're talking standard pressure. However, if we're talking standard temperature, that would be 273 Kelvin or 0 degrees Celsius. Make sure you understand this. This is located on Table A. You can't really see that now, huh? Table A in your Regents reference table. Now, let's review what we learned in this lesson today. Question 1. The arrangement of particles is most ordered in the sample of. Give you a second to answer that. Okay. The answer to this question is 4. Let me explain why. As we've seen, solids are arranged in a tightly packed, orderly arrangement. So, the most ordered arrangement of particles would have to be a solid because they're the most, orderly arrangement like that. They're tightly packed and they're going to be in an orderly set. I keep saying that, but you understand. Now, question 2. When a sample of CO2 solid becomes carbon dioxide gas, there is a change in. The answer here is 4 again. We love 4. The point is, we're going from a solid to a gas. Thus, the particles will start like this, orderly arrangement, as we know, and it will start to kind of split and separate into widely spaced particles like what a gas is. And they'll start to be a lot more spread out. That's why the particle arrangement will change. Okay. Question 3. At 1 atm, equal masses of H2O solid, H2O liquid, and H2O gas have. Now, remember, H2O is water, S stands for solid, L stands for liquid, and G stands for gas. I'll give you a second. This might be a little more challenging, but I think you got this. Okay, so the answer here would be the same. No, I'm just kidding. Different volumes. Let me explain why. 2 would not be right because remember, solids, liquid, and gases have different particle arrangements. As you go from a solid to a liquid to a gas, these particles start to become more spread out. Molecules, particles. So, they would not have the same distance between molecules, so that one is out. Let's talk about that one's out. Now we have 1, 3, and 4. Let's take out 4 because of the fact that 1, we haven't really discussed this topic yet. However, remember, different percent compositions, meaning this would be the percent of a element in that compound. So you have the same amount of H's and the same amount of O's, so the percent composition will not change. So we can cross that out. Now, same density in different volumes. The reason for this is because if we were to have the same density for all 3, that means the volume has to be the same. So that's impossible in this case. However, we can also use our knowledge of chemistry to understand that they're going to have different volumes because solids, liquids, and gases do not have the same particle arrangement. And for example, gases will expand, increasing their volume, and they do not have a definite volume. So that would be question 2. Finally, question 4. Which sample of carbon dioxide, CO2, has the definite shape and definite volume? Remember the particle arrangement, guys. The answer here is 4 again. Well, it's red. Wow, the 4. So, the answer for this, the reason for this, is solids have a definite shape and definite volume. Tightly packed, orderly arrangement. They're not going to take the shape of any containers, and they won't change if you put it in a different container, if you don't make it undergo a change. On the next episode, we will delve into elements, compounds, and mixtures. Thank you for watching, and as always, stay scientific.
Sam's Chemistry Corner.